Hey guys, I'm Natasha and today we are going to do vector product means cross product. Yeah, so in the previous video we have just done scalar product or dot product. Yeah, so today our topic is of vector product. So let's start today's topic, and so let me just first of all write something and then I will tell you about that one. Okay, so let me write it. So this is A vector cross B is equals to vector C, and this is a vector. Okay, yeah, so I've taken an example for you, and it is this vector A cross vector B. Yeah, so we usually call it into or multiply. A multiply by B or A into B. Got it? But in vector product or cross product, it is usually, we always say it cross. So it will be A cross B is equals to vector C. Yeah. So of course I'm saying vector because it, you can see that that vector symbol is mentioned already. So yeah. So it is cross. So A cross B is equals to a vector. Means when we are doing a cross product of these two vectors, we are getting a vector. Got it? And yeah. So and vector has also another name, and it is what I've told you, cross product. Cross product. It is cross product. Yeah. So we can call it as cross product or vector product. Got it? So it has another name and it is cross product. Got it? So yeah. So A cross B is equals to vector C, and vector C is a vector. You all know that, and you can also see through symbol. Got it? So what I'm saying is that we are using cross. So that's how through cross we can say that we are using cross product and we are doing cross product. Yeah. So let me take an example through formula. Okay. Example or formula. Example. Yeah. So I have told you about the torque. Do you remember it? Torque. Yeah, let me just tell you how. Yeah, so it was torque. Okay, and what was the formula for torque? It was R vector cross F vector is equals to torque. Is equals to torque. Got it? Yeah. So what I'm saying is that, and R vectors usually we can call it displacement. Okay, and so displacement into force, and so when we multiply displacement from displacement, or we can say when we do cross of force and displacement, we get torque. Okay, so in this example you can see that we are using torque. Got it? Sorry, we are using cross. So, and you can see that when we multiply these two vectors, we are also getting a vector, and it is a torque. Means it is a torque. Got it? Now let me tell you what is torque. Let me tell you something about torque. Then we will continue. Got it? Then we will continue. Yeah. So I'm going to tell you the definition and explain you a little bit, and then we will continue our topic. Yeah. So I've written what is torque, and so now answer. So let's guess. I hope you all know that what is torque, and if you don't know that, then I'm going to tell you now. And this is an important thing that we should know. So yes, what is torque? So torque is a measure of how much a force. Torque is a measure of how much a force acting on an object So torque is a measure of how much a force acting on an object causes that object to rotate, causes that object to rotate, causes that object to rotate. Got it? Object, wait a second, let me just write it one more time. So yeah, so what it was? Object, that object to rotate. See, so torque is a measure of how much a force acting on an object causes that object to rotate, got it? And so there is a question that object will rotate on what? Actually the object rotate about an axis. So the object rotates about an axis. See, the object rotates about an axis. And we can call it pivot point. What we can call it? We can call it as pivot point. See, so torque is a measure of how much a force acting on an object causes that object to rotate, and the object rotates about an axis, and we can call it as pivot point. Okay, so it is saying that what will be our pivot point? Actually the object means on axis on which the object is rotating, we can call it as pivot point. Got it? Yeah, so torque is a measure of how much a force acting on an object causes that object to rotate, and the object rotates about an axis, and we can also call it as pivot point. Got it? So I hope you all have understood the main definition of torque. So this was torque, and so now let's continue. So let's get back to our topic. So, and it was our cross product or what? Or vector product. Yeah, so let me just continue. So now we are going to find magnitude of vector C. Okay, so magnitude of vector C, or yes, or okay, yeah, so I told you that this will be a vector C, but we can also write it as A cross B. Yes, is it right or not? Of course it is right. Yes, how? And if you already know that, that's really good. No, I'm not going to mark cross. Normally A cross B. Yeah. So magnitude of A, then cross B. Yeah, so we can call it as vector C or A cross B. What? A cross B, A cross B. Not A into B. Okay. Actually we are doing cross product, so just don't say cross. Sorry. Just don't say it into. We are going to say it cross. A cross B, C cross D, or any other alphabet or any other vector. Yeah. So magnitude of vector C or vector A cross B. Yeah. So wait a second. So we were doing magnitude of vector C or A cross B. So before doing a magnitude of vector C, I have to ask you a question. So can vector product be negative? Can vector product of two vectors be negative? Yes? Actually, no, never, never, ever. So how? Let me just tell you. So yeah, it is never. Why? Because the cross product of two vectors is itself a vector, and vectors do not have a meaningful notion of positive or negative. Got it? Got it? So that's how you can say that vector product of two vectors can never be negative. Got it? It will always be in positive. Positive. Got it? Yeah. So let us continue. Yeah. So magnitude of vector C or vector A cross vector B. Yeah. So yeah, we are finding magnitude. So what we are going to use? Mod. So mod of what? Vector C, of course. Vector C, of course. Yeah. So vector C mod C is equals to what? Mod A mod B cos what? Cos? No, cos will not be used. Cos will not be used. Sine will be used in vector product. Sine. Got it? Sine. Sine theta. See? Vector mod A, mod B, sine theta, and vector sign will also not be mentioned. Don't forget to write here sine, because if you write cos, then you will get 0 marks of that, and your whole answer can be wrong by a small mistake. Got it? So always remember that in vector product we will use sine. Got it? And after some time I'm going to tell you why sine will come and cos will not come. So let us continue. So it was vector A cross vector B. So mod A cross B. See, mod A cross B. Then what? And we can also say it as AB sine theta. AB sine theta. See, AB sine theta. AB sine theta. Okay. And how? Sine. So I am going to tell you now. Yeah. So this is a vector B. This is our vector A. This is our vector B. This is our vector A. Got it? And what we are going to do is now that where is our theta? Where will be our theta? Yes. Where will be our theta? Our theta will be here. Here. And so sine is using because the remaining one means whole revolution means 360 degree. But we don't know that what we are going to means from which we are going to minus theta. We can but according to the question we will do it. Suppose 90 degrees coming, so 90 minus theta, 360 degree is coming, so 360 minus theta. Got it? And so sine will come. Sine will come in vector product or cross product. Got it? And yeah, and I'm going to tell you something really important. Okay? So it is what will be a theta? Means, no, I'm not saying that tell me the value of theta. I'm saying that what is theta? What is theta in vector product? Actually, theta is the smaller. Theta is what? Guess what it will be? Theta is what? Theta is what? Guys, tell me. Okay. So just pause the video and guess what will be our theta in vector product. Okay. 5, 4, 3, 2, and 1. Yeah. So theta will be our. Let me write it by another way. So yeah. Theta will be our smaller of the two angles, smaller of the two angles Yeah, so in cross product, this means that theta will be our smaller of the two angles. Theta will be our smaller of the two angles. See, actually it is like this. Got it? It is like this. So this will be our theta. This is our vector A, this is our vector B. So this is our theta. See? Got it? Yeah. So what we are going to do? Yeah. So theta will be our smaller of the two angles. Theta will be our smaller of the two angles. Theta will be our smaller of the two angles between vector A and B. Don't forget, this is really important. Theta is the smaller of the two angles between vector A and vector B. But in normal simple language, what was the theta? It was the angle between vector A and vector B. Means between two vectors. Between two vectors, the theta was the angle between those two vectors. But in vector products, theta is the smaller of the two angles between vector A and vector B. Between what? Between vector A and vector B. Between vector A and vector B. Remember it, okay? Don't forget. And it is a really interesting thing to remember, and you can just remember it by this small definition, small line, smaller of the two angles between vector A and vector B. You can also note it. Okay? Yeah. So theta is smaller of the two angles between vector A and vector B. So, and you should know that smaller of the two angles between vector A and vector B. No. We should know. I also should know. So it is smaller of the two angles between vector A and vector B. This is really important topic. It is really important thing. That's why I am telling you. So we all should know. So take it. It's really important. Yeah. So that's all for today. And vector product is not finished because we are going to do some special cases of vector product, some properties of vector product, and then only our vector product will be finished. And we are soon going to take a question of vector product. And so in the next video, in another video, I'm going to tell you about the direction of vector C, or we can say it vector A cross B. Got it? So magnitude, mod for magnitude and cap for direction. Mod for magnitude and cap for direction. Mod for magnitude, cap for direction. Got it? Always remember it. Yeah. And so, that's it. So, thanks for watching and have a nice day.